automated ticket gate. How do these gates, at one of London's busiest underground stations, open and close over 20,000 times a day without crushing travelers in their powerful grip? Hidden inside a tough stainless steel casing, 56,000 individual parts work together. Two mighty electric motors that can open and shut the gate in a fraction of a second. A super fast ticket shuttling system that processes each one in under 2 seconds. Between the steel gate posts, two tough polyurethane panels made from the same material as truck fenders open and shut in unison to move you through the gate at lightning speed. The key to this machine's speed lies in the innovative design of the ticket reader. It must be fast enough to check over 1,000 every hour without misreading a single one. Engineers at this factory in Tennessee build more automated readers than anywhere else in the world. They must be able to read tickets faster than the human eye.
Well, the faster we process the card, the more people we can get through the walkway, and the less queues we have.
Kevin's goal is to make a robotic gate that can read 33 tickets every minute. The secret lies in the magnetic stripe on the back.
The magnetic stripe contains the data that the gate will use to determine whether or not the customer has a valid ticket or not.
Kevin installs an ingenious device to read this hidden data.
So I'm going to install the magnetic head assembly. This would be the eyes of the gate. Without these, the gate has no way of reading what's on this card.
For the machine to work, it must physically pull the card past the magnetic reader and return it back into your hand in less than 2 seconds. Behind a small slot where it enters, a miniature electric motor spinning 6,000 times a minute drives 7 toughened PVC rollers and 2 rubber belts. The belts pull the ticket over half a yard every second. The magnetic reader checks it. If it's your final journey, the rollers divert it into a bin below. If it's still valid for more journeys, the machine shoots it back into your hand. The data on the card controls the movement of the gate's paddles. They must know when it's safe to open or close. If the paddles open or shut when someone's in the way, they could hit them. If a ticket gate's powerful paddles open or close when someone's in the way, they could hurt them. So workers build in special detectors to protect commuters.
The safety features check the area to make sure that there's not an obstruction in the walkway.
Mark installs the all-important safety devices.
Now we're going to be installing the beam sensors into the gate. These are optical sensors, infrared LED visible light beam. There are 5 beam sensors in each walkway. One side of the walkway will have all 5 beam sensors, and the opposite side of the walkway will have the reflector.
Each reflector bounces the light beam back to its sensor. If this beam is interrupted, the system senses that a person is walking through.
The paddles are not going to close until all of those beams are clear.
With a valid ticket and a clear path, the machine must open and close in the blink of an eye. This is how it works. Two exactly synchronized, powerful electric motors drive each gate. Inside them, 330 yards of copper wire and strong electromagnets spin 2,000 times a minute. A set of gears controls how fast the paddles open and close. The sensors on top detect if anyone tries to dodge or hold them open. This secret machinery is the key to moving billions of travelers worldwide every year.
No belt.
The machine's powerful motors sit inside the base of the gate's posts. Craftsmen must build columns strong enough to withstand the motor's force. They add extra thick stainless steel to each base to prevent the metal twisting under the strain. The team sets the finished gates on an automated cycle overnight. Over 12 hours, they open and close more than 4,000 times. This robotic inspector helps millions of travelers a day board their trains on time, with barely a human inspector in sight. The refrigerator.